Okay, so as Mary said, the talk's on seriously open cloud native Java microservices. We've introduced ourselves, so I'll start on the content. Well, I guess I'll start by asking a few questions. So I guess you all work with Java. You're at a CJUG. Yep. What do you do? Server-side application development? Is it that kind of thing, or right? Who works on monolithic applications? Who works on microservices? What do you work on?
So we're in IT professional services, so we help build teams for different clients. So we just like to stay in the loop from a technical perspective.
So is that kind of consultancy type things?
Yeah.
That kind of, cool. Are you similar? Or
Actually, I am a certified Scrum Master, project manager. I build cell towers for AT&T. I manage at the software part, so I just want to learn over Java.
All right, cool. Okay, thank you. All right. So the talk we've got quite a lot of slides, so I'm going to rattle through them quite quickly. So there'll be a little bit of background on enterprise Java and also industry trends and evolution and how that's influencing enterprise Java. We'll talk a bit about Eclipse MicroProfile, so I'll hand over at that point, and Emily will take you through Eclipse MicroProfile and Eclipse Jakarta EE, and then talk about the combination of the two technologies and integration with the cloud, and then I'll talk a little bit about JVM considerations, because not all JVMs are created equal, and then we'll have a summary, and then a bit of social and pizza maybe at the end. And feel free to go and get the pizza during. I don't mind if you get up. I prefer you not to walk out. But okay. So I started a few presentations within the beginning, and I realised this morning that's probably a lie. So not quite the beginning, but in the beginning for enterprise Java was all about specifications. So a bunch of companies got together and started defining APIs for doing enterprise Java. And that started in the kind of late 1990s. So 1998, the initial specs were being defined and released, and then it evolved over the years. And you're probably familiar, you've all heard of Java EE. Yep. So you're familiar with how that kind of evolved over the years from kind of a small number of specifications up to the point where we had something in the region of, I think it was 30 odd specifications in Java EE 8. And of course, along the way, the runtimes were required to implement all of these specifications, and they just evolved as the specifications evolved, and we ended up with runtimes that were, let me say, not particularly small. They were, because the focus on the industry, we were doing things like waterfall, and that was waterfall both in development and release of software, but also waterfall in terms of companies doing deployments of the software. So because that was a big task, once they deployed it, they wanted that thing to stay up for a long time. So the focus was on operations rather than on the developer experience. But along the way, something happened called Agile. So who here does waterfall still? I'm going to put my arm down because I don't want anything.
I'm both.
Yeah?
Waterfall and Agile.
Yeah.
Because my company, they needed like Agile project manager who can like do like a hybrid thing.
Right.
Because I work with AT&T and it's a big company.
Yeah.
So they cannot like transfer immediately from the waterfall to Agile.
Yeah. Yeah, I've seen that. I've also seen some companies who intentionally remain waterfall because of the types of things they're creating, like air traffic control systems. You probably don't want... You want collision detections to be there kind of when you release it, rather than, okay, that's coming in the next iteration, sort of thing. Around the kind of early 2000s, Agile was a kind of backlash against failed projects that were doing waterfall methodology. So the products that Mike and myself worked on were doing waterfall, and we'd do a release and we'd say, okay, next one's going to be in a year's time, or maybe we'd even say 2 years' time, and we'd do our development and carry on, and everything would look fine, or at least we'd be head in the sands and not knowing that things weren't fine. And then we get close to the point where we wanted to release and realize we were actually nowhere close. And what had happened along the way was, because people knew that the next release cycle was going to be in 2 years' time, they didn't want to miss the current boat. So they would cram things in, and the industry would change, and we'd cram new things in, and we'd get scope creep. And so we'd say it's going to be this year, but then it'd end up being a year later, and then we'd just repeat the cycle again. And so in order to break that cycle, Agile came about. Agile iterations, you can deliver production-ready content on a 2-weekly, 4-weekly basis, and therefore there's not this fight to try and get your content in. It goes when it's ready, rather than I've got to get this in the next release. I must get this in the next release. So that was great from a development perspective, but then we kind of bump up against the operations side of things. So you're doing agile development. The idea of agile development, create something that you can actually use. It delivers value at the end of each iteration. And then you hit the operations problem where in a lot of the customers I work with, they've got development teams, they've got operations teams. You throw the application over the wall to the ops team and they go, thank you very much. Okay, we'll put it into production in 3 months' time. And it's kind of, well, what's the point of the development team delivering value every 2 weeks when the operations team can only deliver value once a quarter? So this is where kind of DevOps comes in. So you start adopting kind of developer-style practices, infrastructure as code and so on, so you automate the heck out of everything. And then you can therefore do agile operations. Of course, the next thing you bump up against is infrastructure. So a lot of companies have on-premise infrastructure, and they have to go through requisition cycles to actually get new hardware for new applications. And so there's a lot of planning, a lot of sign-off. You get it delivered, it gets provisioned into the data center, it's eventually available for you to do your deployment. So if you've got infrastructure going at those long cycles, then you bump up against the infrastructure problem. And this is where cloud comes in. Cloud essentially enables you to have agile infrastructure. So that's great. So we've got agile going all the way through. We can put something into production, but and kind of not necessarily related to agile, but so I worked on modularity technology for many years, and I won't mention the name. All right, it's Jiang. And I worked with a lot of customers who had monolithic applications, and we still have lots of customers who have monolithic applications, and they were saying we need to break this down into more manageable pieces. We don't actually know what the architecture is of this thing internally. If we make a change over here, we get these strange side effects happening over here. So that meant they were, rather than being able to in an agile way deliver updates to these applications, they were fighting against, the application was fighting back. And this is where microservices comes in. So the idea of breaking down the application into a set of collaborating smaller applications, if you like, or microservices that are owned by individual teams and therefore can be evolved independently. They have to be evolved in a mature way in terms of compatibility of APIs that you present to your consumers and so on. But if you have those good practices in place, then you can independently evolve the microservices, which means you can, in an agile way, deliver new value frequently without actually having to necessarily have these tight couplings between the components and tight couplings between the teams. All right, so that was one thing that happened, but then also another thing happened. Can you see that at the back okay? All right, so the way in which companies bought software changed. So in the old days, I say the old days, I was around then, proprietary software was the thing. Companies like IBM, Oracle, etc. produced software and we sold it to the CIO, and the CIO said, right, there you go, team, deploy this, and they'd be like, okay, thank you very much. And then we kind of moved through a kind of freemium world, and then eventually into open source. And so we're now at the point where pretty much companies and government organizations and so on essentially demand that you provide open source. And then the great thing about open source is you can try it, there's no strings attached. You can even, if you choose the right open source, you can put it into production with no strings attached. And then if you decide it's providing value to you and you're doing something that's mission critical, you can choose to pay for it. All right, so that doesn't really fit very well with the kind of what I presented as the Java EE, the initial enterprise Java world, where essentially the platform itself was a monolith. It had APIs that weren't really designed necessarily for the agile world, and also a lot of the runtimes weren't necessarily designed to be developed on and deployed to in an agile way. So the industry needed to evolve. And in terms of a few requirements, well, we needed a way of delivering agile specifications. So if you think back to the Java EE specification process and that original slide, we were talking about years between spec deliveries, platform deliveries. So we need to be able to deliver specifications in an agile way. The implementations need to be delivered in an agile way. There's no point delivering a new specification if you then need to wait a year before implementations come out. We need open source communities. So essentially, move the relevant technologies to open source, and we've seen this happening and it's pretty much happened in the industry completely. Open governance. So you want to be able to pick technologies, pick specifications, and so on that are in an openly governed community. You don't want something that's dictated by a particular vendor, for example. And then, as I said, open source. So you want open source implementation, so you can try them, no strings attached, and then pay if you want support. So this is where Eclipse MicroProfile comes in.
Hooray! MicroProfile comes to rescue. Have you all heard about MicroProfile? Okay. Eclipse. Okay. Good.
When you think when you think of Eclipse, what do you think? Right.
Yeah.
So you need to get that out of your brain?
Yes.
So I don't know if you're aware, but Eclipse does, I mean, it started out as an IDE. For many years it's done runtime technologies, so there is a group or a part of Eclipse that's designed for producing runtime implementations. So Eclipse Equinox as a kind of foundational technology there, and a bunch of other technologies. And Emily's going to talk about how Eclipse is also evolving to do specs. So
yeah.
don't just think tools.
Yeah, it's actually like this is a kind of common mistake, and Eclipse Foundation realized this. Actually, last year they redesigned the logo. Previously, Eclipse, everybody, a lot of people associate Eclipse with IDEs. Now they have a brand new logo, but need time to educate people. Eclipse Foundation has many things. One part is IDE, other part is all the open source projects. So MicroProfile is under Eclipse Foundation. What is MicroProfile? First thing is not Eclipse IDE and nothing to do with IDE. It is an open source community, and the community come together to evolve the best breed Java-based programming model for doing microservices. So this is what MicroProfile about. It has companies involved like IBM, Red Hat, Piara, Tommy Tribe, and other like Java community, like Java, London Java community, So Java, and also including some other individuals. And any of you are welcome to join this community to contribute. And this community is really open and welcoming. So as I mentioned earlier, so this is the players and for this project, like IBM and originally IBM, Red Hat, Tommy Tribe, Piara, London Java community, the main force, and later on Oracle, Lightbend, Microsoft, Hizocast, Fujitsu all joined. And then they're still there. And then the community is expanding very fast. And we have a lot contributors and for these open source projects. Over 140 individual contributors, half a dozen independent implementation. Actually, I lead a few, 3 specifications. I work with some individuals. They don't work for a particular company. They just work on this specification for fun in their spare time. So you can see this project is really fun. And this is we just trying to list. The locations. You can see it's spread across the continents. So it's all over the places. Actually, this year and even reached to China. Last year, I was invited by the quite big conference, QCon in Shanghai, to talk about MicroProfile. Actually, I was really pleased that they even know about MicroProfile, because MicroProfile being around only for about 3 years. It's a kind of pretty new compare with some other technology being around for more than 10 years, 20 years, and etc. So it's really, really good. So how do we communicate? We use all kinds of things, and originally, because I led the first stack, which is called MicroProfile config. So basically, I became a path founder. I said, how can we communicate? I said, okay, need to be free and people free to join. So discovered this Google Hangout. So I opened a Google Hangout and etc. And since the email communication, we use Google Groups. And also we have a website, MicroProfile.io. Later on, we have a link to give away. And we have a bi-weekly, all community kind of hangout. Basically, we all join together, and then we discuss all kind of issues and plan ahead. So it's really good. And then we publish the recording to YouTube channel. So it's Graham later on said MicroProfile is about APIs, and APIs cannot do much if you don't have an implementation. And if you want to make this API can work for you, you need the implementation. So it's in MicroProfile we have a lot of implementations to support this API, like Open Liberty, which is an open source project. Both I think nearly all of us, like 5 of us, all work on this project, Open Liberty. And also it's Red Hat has Songtail, and then this is Tommy Tribe has Tommy EE, Apache Launcher, this is Fujitsu, this is from Oracle Helidon, Cumulus EE, this is quite a small one, and this is open in the Apache Hammock. So this is someone, individual created this one, doesn't owned by any particular company. And also this is Payara, so it's kind of owned by Payara. His also is Graham mentioned earlier. We want kind of moving rapidly community, and you can release fast, and then what's in demand, and we fix we just come up with a solution to meet the requirement. MicroProfile does exactly that. So in the it started in 2016. Now within these 3 years, look, we have about 9 releases. We released MicroProfile 3.0 in June, and then in a few weeks' time, in October, we are going to release MicroProfile 3.1. So let's have a look. Okay, I talk a lot about MicroProfile. It's a great, open, completely open community. So what does it do? What kind of things does it produce? So it's I mentioned it produces APIs for doing cloud native microservices. What do these APIs look like? So the first thing is how can I create my first microservices? When you create a microservice, you need the very common microservice is use REST is a RESTful microservice. Basically, you need to post a URL, so your client, your customer can go to the browser and then poke this URL and to get a response. So how can I achieve that? So you can use the JAX-RS, and obviously we all want to tidy house. You want to create a loosely coupled microservice. We use the CDI, basically does all the context-dependent injection. The other thing is when the customer comes to visit your microservice, and obviously they post a request and you post a response to them. In what kind of format? So it's the JSON format is very kind of widely used. So that we use JSON-B and JSON-P. And with JAX-RS, CDI, JSON-B, and JSON-P, you can create your first microservice. Obviously, microservice is a kind of small application. And 99% of the time, it needs to use call the backend, call into another service to do more things. So you need to connect with them. And once you form this connection or this kind of network, And you will have one client, one server. The caller will become a client, the backend will become a server. So how can you link with them? How can you establish the link? So you use a REST client. So I will go through them, give you a quick example as well. So here, how can you create a JAX-RS? So basically, you need to expose the kind of endpoint. The first thing you need to create a class like extend the application. So this is more like a root. The other thing is the JAX-RS resources. You can create as many resources as you want. Like here, but in microservices, normally you for monoliths you might have many endpoints. For microservice, most of the time you just have one JAX-RS resources. So you can say, okay, here this is the kind of format, it's a JSON format, and get property will be posted as a JSON format. When you poke this URL, will be a host and port and then system properties, you will get a JSON object back. So this is JAX-RS. The other thing is the CDI. Do you know how many of you have a Java EE background? None? Okay. For CDI, are you Java developer? Or you are Java developer? Okay, you are not. Okay, you are kind of operation, right? Okay, I keep it very simple. Okay, so for CDI, so one thing is all this one. If things with at blah blah, this we call it annotation. So here, if you have the annotation like at inject, so the CDI, so this one, will create an instance and then populate into this system client, this variable. So once this line kind of executed this variable, when I say variable, you understand? Yeah? Variable is something you can put things in. Yeah, will be populated. So this is CDI. So with this, you can achieve a loosely coupled microservice. So the next one is I mentioned the JSON. So JSON in this kind of control the payload. So this is microservice is kind of response in a JSON payload, and all you need to do is create the class with same inventory list as in here, and the JSON will automatically when it's trying to push to the wire, it will serialize it. It's almost like the package it up, and then when it reaches to the other end, JSON will unpack it so the user can see what's in it. So this is JSON. So this is establish this link from A to B. How can you establish this link? Obviously, you need to find out what's in here, right? So how can I declare what's in here? So you use this class. So you use this annotation at register REST client, and then describe what's the interface. What's this interface, or like a socket? If you don't know interface, it's like a socket thing. And then it's what's in this interface. Like this is a method get properties. And then you can directly saying, okay, this is the interface is get properties, and then I can inject into my a service. This is the client, and then you need to establish this from here to here. You use this property. So basically, B live in under this URL, and this is with this property specified with this value. A can find out, okay, B live here. I can automatically invoke B via this URL. So this is JAX-RS. So it's up to now you can create your first 2 microservices, and with these 5 things, and then they can talk to each other. So what will happen if you hundreds of these services? And how can you ensure they are secure, or you can easily configure them, and etc. And then also you can document them, and to see if you have hundreds of people or hundreds of employees, and etc. You need to make sure sometimes they might need to wear the name badge so that you can remember their name, right? So hence we have OpenAPI. OpenAPI is the way to document microservices. Basically, it's saying, okay, what you are known with. So what's your name and what you can do, this kind of thing. And if you have hundreds of microservices, they are all in the wild, and you need to secure them because for some of them might carry very sensitive information, like check salary or find out how old you are. We don't want to have our age be revealed, right? So it's you need to secure them. And also the other thing is, if you think a microservice, you need to think about the other child. Yeah, sometimes they do not respond, and sometimes they might be really lazy, right? And sometimes they might go somewhere without telling the parents where they are. So you need to be a fairy godmother. So no matter what the children behave, and you can always present well to the client, to the customer. So that's why you need to be a very resilient microservice. You do not need to rely on the backend's behavior. Maybe the backend is not behaving well, but you need to cope with that situation. The other thing is when you create a microservice, it could be deployed anywhere, right? You want to configure it differently. So you do not want to change the code if it's you just change a username or password. You want to externalize this kind of information in the infrastructure so that you can easily configure them. So I will go through this. So the first thing is how to document it. So the way to document the microservice, we use the MicroProfile OpenAPI. So OpenAPI is once you use the OpenAPI, the URL, local host, and then port and /API. Once you invoke this URL, and you will get this response. So this is if you know Swagger. Have you heard of Swagger? No? Okay. If you have heard Swagger, this is kind of identical to Swagger. And in OpenLiberty, we also have this endpoint, OpenAPI/UI. You can directly go to it's a UI version, and you can directly invoke individual endpoint. And then it will also tell you what this per endpoint, what they are doing, and etc. So this is the following one, how to secure microservice. So it's like a secure microservice is quite simple. You just say, okay, this endpoint, like in this one, I only allow someone with admin or user can invoke these resources. If you are like some other roles, like a student, you are not allowed to invoke this. In MicroProfile JWT, basically, when you invoke the microservice, the MicroProfile JWT basically is a pass token, JWT token. Inside that token, it buries the user information. Also, it buries users' access rules information. So in this case, when the backend received this token, and it will open up and find out, oh, what your role is. If the role is saying student, so you can go back. So you're not allowed to access me. So the next one is, as I said, is how can you build a fairy godmother microservice. Basically, it can always function no matter what, right? It has magic. So it's in the MicroProfile for tolerance, we have this kind of retry, circuit breaker, and bulkhead, and also fallback. So for the fallback is basically if you use all the method cannot fix a problem, okay, you can invoke an alternative service. So for example, give you like one example. If you build a microservice, basically you want to publish a message to social media, right? And the first, in your design, you publish it to Twitter. And for some reason, maybe Twitter server is not working. In your fallback, maybe you can automatically publish it to LinkedIn. So this could be like a fallback. So the next one is how can I configure my microservices without having to redo, recode, release my microservice? Is to use MicroProfile config. So basically, you can, I mentioned the app inject. You can directly inject a particular property into your microservices. So in this example, I directly inject this long property into the in maintenance this variable. And I can specify this property in some other places, or I could specify it inside my microservice when the developer first develop this microservices and I put a value false. And later on DevOps, if you work in DevOps, maybe you say, it's in production and is kind of, but is tonight I'm going to take I'm going to recycle my service, and you say, I put a maintenance to true. In this case, like this microservice have go through this code and say, in maintenance being reset to true, and then here you will get a true. So it's all this is called config sources. They all got a priority. The one with a high priority will overwrite the one with the lower priority. So this is MicroProfile config. So what if you have hundreds of microservices, and you might be wondering how well they are doing, right? So it's wondering how fast they can respond, how many requests they will receive within a given period. So you need to see whether this microservice is ready to receive traffic, or whether this microservice is dead or not, and etc. So we have this health check metrics and open tracing to help you, to give you all this kind of information. This information is very, very important for the DevOps, so they can monitor this microservice. So the first one is the MicroProfile health. So this one is basically for this microservice to be able to communicate with the cloud infrastructure or with the infrastructure environment to see whether you are well or whether you are ready to serve any request. So here, you can directly annotate at readiness, and then you will automatically get a /health/ready this endpoint. And then when you poke that endpoint, you will get a response like this. And obviously, you can put some business logic here. For example, here, if it's you rely on the database, if the database is not responding, you cannot connect to the database here, and here is you will say if it cannot connect to the database, return will be down like that. And then this is when you poke that URL, you will get a down instead of up. So the next one is metrics. So this is a metrics basically can tell you how fast this backend responding. So you can use at time annotation, and then this one will automatically give you an endpoint /metrics. When you poke them /metrics, you will get all the data, how fast this backend responding, and how much traffic it received at a given time, and etc. So the next one is I mentioned earlier, you could have hundreds of microservices or even thousands of microservices. Maybe in a given operation, 20 microservices involved. However, that given operation didn't respond in time, and there's some failure. You need to find a way to find out which microservice is not working, right? You need to work out which microservice I need to take down, I need to fix it. So without any like a graphic kind of view, it's really hard to use a piece of paper to figure out, okay, which microservice, this request went through. So that's why the MicroProfile Open Tracing comes in to help you. Basically, it is like a established thread for you. Basically, it propagates a correlation ID. It's almost like pass a torch from 1 to B and B to C. And eventually you can trace, okay, the torch is from A to Z. So that like some other tools like Zipkin or Jaeger be able to draw a graph for you. So you can see that graph and find out, okay, the F is kind of slowing down, it didn't respond. So you can figure it out. The good thing is with MicroProfile Open Tracing is all the JAX-RS method are automatically traced. And if you want to have any more additional trace, you can add annotation, add traced, and same operation name. So you can see these kind of things in some other third-party tools. Okay, up to now, I pretty much went through all of the MicroProfile capabilities. And MicroProfile is still like under active development. We have more APIs in the making. And recently we released reactive messaging, reactive stream operators, and context propagation, and also the LRA. This is for transaction, long-running action. And this is the kind of query language, GraphQL. So they are to be released. So it's hopefully released in next month also. I'll give you a quick overview what is reactive messaging like. So this is a way. Have you heard of Kafka? Kafka? Yeah, you all heard. Oh, that's good. Kafka is you all heard of it. So it's about messaging, right? And so in MicroProfile, our first candidate is how can we make sure microservice can communicate with Kafka very easily, right? You don't want to write a lot of code and to be able to send a message to Kafka and retrieve the message from Kafka. So basically, we come up with two annotations. Add incoming means I consume a message from Kafka, right? Add outgoing, I publish a message to Kafka. So in this example here, I can say, okay, I'm a consumer. Also, I'm like a publisher. Basically, I also publish to the message to Kafka. So I can receive a message, and then I manipulate this message, and then I push it back to Kafka. So how can I, with this microservice, obviously I need to find out where Kafka lives. So we use this configuration to specify where this Kafka host. So it's the host 9092. And also we need to, so here, this is Kafka host. Basically this is incoming. This is MP.messaging. This is all the prefix. And this is incoming there. Corresponding to this incoming, and this is channel name greeting in. Is a kind of this is equivalent to the Kafka topic. So actually I said that we targeted for Kafka, and this these annotations, they can work with some other messaging brokers such as RabbitMQ or ActiveMQ and something else, or also maybe it's IBM MQ. So all these kind of messaging brokers all have potential to be able to work with MicroProfile reactive messaging. So next one is GraphQL. Have you heard of GraphQL? Some of you? Okay, good. So it's a query language. Give it you in layman's term is it fixes a problem overfetching or underfetching. Overfetching means that you get a lot of information and then you filter out, okay, I want to use one thing. This is called overfetching. Underfetching is mean, okay, I need my username, I need a password. It fetched twice. First time I fetch my username, and second time I fetch my password. Obviously, this is not good enough, right? It needs to go twice, and then respond is slow. So GraphQL basically is just to give you what you need, right? Just with one time. It's a query language. And then it's come up with some other APIs is the same GraphQL, and also the query and the mutation and etc. This one has not been released. All these things, might change, but maybe it's kind of stable enough. Okay, I have done a lot on MicroProfile, and sometimes it's still not enough. You need more things to work with MicroProfile. And MicroProfile was here to for the cloud native development. Also, it uses some Java EE technologies. But to make MicroProfile even more powerful is we need we still need Java EE. The Java EE previously, have you heard of Java EE? Yeah, good. Previously was owned by Oracle. 2 years ago, Oracle saw MicroProfile is kind of really active and really successful. Oracle saying, okay, I want to donate some Java EE somewhere else. And then it's talked to two open source vendors. One is Apache, the other one is the Eclipse Foundation. And Eclipse Foundation said, wow, this is really good because I have MicroProfile already, and welcome Java EE to join the Eclipse Foundation. And then it's because Java is kind of trademark. Oracle saying you are not allowed to use Java. You need to come up with a different name. And then it's the community, the Java community, actually is, I still remember during Christmas time, I still stayed quite late and trying to work out which name I should nominate. So eventually someone come up with the name Jakarta. Do you know the Jakarta? Yeah, Jakarta is kind of the Java home, right? So this is a really cool name. The other thing, the Jakarta actually was used by one Apache project, but it's become dormant. They don't need it anymore. And then we have to Eclipse, the community has to speak to the Apache Foundation, say, can we reuse this one? Eventually they donate the Jakarta to Eclipse. So we now use Jakarta. So Java EE now become Jakarta EE. As you see, IBM, Oracle, and also Red Hat, all these bigger players still behind the Jakarta EE. Jakarta EE has changed, a lot from Java EE. There's a bigger change between Java EE and Jakarta EE. Java EE was controlled by JCP, so this is kind of the community. And now Jakarta EE is controlled by the Eclipse Foundation stack process. So it's basically the JCP, here is the JCP, is a specification first. It means you write a documentation first. You document what these things are supposed to do. And in Jakarta EE, you write your code first. And also the JCP, you do all the things, the decision be made by spec lead. And actually, I was in the CDI expert group. So basically, if we have some dispute and etc., and normally the spec committee will make a decision. So it's in the Jakarta EE is everyone has an equal voice, we collaboratively work together. And also the documentation TCK are closed source under JCP. You are not allowed to see the TCK. TCK means test toolkit. And Jakarta EE, everything is open. And this is in JCP kind of, you publish a spec. However, you have one implementation is called as reference implementation. Almost like this golden boy. All the others kind of not less favored. obviously each specification has a few implementations, but only one reference implementation. In Jakarta EE, you have compatible implementation. Is a kind of they are all equal. And in GCP is we use the Oracle certification process, and in Eclipse Foundation, everyone feel free to self-certify. Okay, so only recently we had released the Jakarta EE 8, and then Open Liberty. Glassfish is the first one is trial to pass the all the TCK, and Open Liberty is the first production server to pass the Jakarta EE. I need to make it really fast now, conscious of time. As I mentioned earlier, MicroProfile also need Jakarta EE to be really powerful. So this is not only I said this. Actually, a lot of people tweet on Twitter and saying MicroProfile plus Jakarta EE equals really powerful. So here is the kind of MicroProfile and then Jakarta EE. Jakarta EE and then come together. They are complementary to each other, and also there's kind of a lot community behind both effort. This is latest MicroProfile 3, so you have all these 8 specifications. This is from Java EE, now Jakarta EE. And in Liberty, and we are strong supporter for both MicroProfile and Jakarta EE. So since the beginning of MicroProfile, 3 years ago, we were first to certify against 1.0. And then in July this year, we certify against MicroProfile 3.0. Considering 3.0 was only released in June, and in July we passed all the TCKs. So that's our Open Liberty. This logo is really cool. Go to the space, right? So it's Open Liberty is under openliberty.io, and you can download Open Liberty. It's completely free, and you can use it in production. And then we welcome any contributions as well. However, you can buy support if you want. And so this is bigger picture put all together. This is all from Java EE, and this is all from the MicroProfile. And you can mix them together. You can specify in your project, if you do Maven, you can specify which APIs you need. And then if you need more, you can specify more. And in this case, when you do the coding, only these APIs will be available to you. And then you can build a really small runtime. You can just take a really small runtime as well. Okay, I talked a lot about MicroProfile, Jakarta EE, doing your application. I haven't talked much about cloud. So this presentation is about cloud native, right? So what kind of these things, these technologies, have something to do with the cloud? So how can you put in the context of cloud? So it's in the cloud, the first thing you need to fix the problem. How can I ship things into the cloud? When you move a house, right, and then you need to pack things, right? So it's similarly, when you ship the microservices to the cloud, the first thing you need to pack them. So what kind of things can you use to pack them? So you use Docker. Containerize the tool. So after you containerize it, you need to manage them. Now it's a lot of containers. You need some containers maybe is kind of broken. You need to fix it. So it's Kubernetes is a kind of thing, is a tool be able to fix manage containers. And once there's a lot of microservices, a lot of containers, and etc., you need to manage all these services. you need to secure them more, and etc., you will need EC2. So this is all the cloud infrastructure. So this is quick is about Docker. For Docker, you can create a container, use Docker build. And then you can push the container into a lorry. You do a Docker pull, for example, you push to the lorry. And then you can do a Docker run, it kind of run the things inside the container. So it's the Docker registry, you think about this is like a lorry or like somewhere else. So this is the command to build this container. This is the Docker run, to run the container. Run inside the things inside the container. So this is Kubernetes. Basically, is manage the containers. So it's like a Kubernetes has this is your UI command line, and this is the Kubernetes cluster. So you have one cluster. You can have many nodes. Each node is kind of like a physical machine for you, and each physical machine can have many pods. Pod is the smallest unit managed by Kubernetes. Why is the smallest unit? Is because Kubernetes can kill this one and then create a new one. And if you put a lot of images inside, they will die together once Kubernetes gets rid of them. So this is a kind of way to explain Kubernetes. So it's I talk about MicroProfile, Jakarta EE, and cloud infrastructure, and how can they work together. So MicroProfile config work really nicely with Kubernetes. Kubernetes can be used as one of the config sources. So you can create the property, like a config map, like a property messaging equals greeting, and then you can map to the environment variable, and then you can inject into the application. So in this case, this is the property greeting, and you find greeting environment variable, and then you find the key is the message, and then you will get inject greetings into the variable greeting. So this is kind of your application can communicate with the cloud infrastructure. So the next one is your container and need to be able to be intelligent. Is able to express its feelings. How can you express its feelings? Basically, if you are not feeling well, maybe you say, okay, container, please destroy me, I'm not feeling well. Or if you are not ready, you can say to the cloud infrastructure is not ready. So we use the in Kubernetes is something called readiness probe. So you can directly the Kubernetes can poke this URL /health/ready, and we say if you return down, Kubernetes will automatically kill this pod and then stand up a new one. So this is maybe I'll quickly go through the EC2. EC2 basically is it has two things. One is the control plane, there's a data plane. So one of the bigger things this is kind of proxy. Basically is once you use EC2, you deploy the service to EC2, and the service don't talk to each other anymore. They go through the envoy proxy, and the proxy can talk to the backend. So in this case, you almost one service have a request going out. That request being packaged with extra layer. That extra layer is very powerful. That extra layer can add a lot of quality service. Can add extra securities. You say, okay, even if you're calling unsecured backend, I can make sure the transport layer is secured. So this is kind of thing. Okay, I think it's covered cloud and your microservice. Obviously, we talk about Java. What about JVM? Graham, you have a go with the JVM.
Okay. Yeah, so we've seen how at the start we talked about enterprise Java and how it evolved in a kind of waterfall way and kind of led to monolithic runtimes, monolithic applications, and monolithic kind of specification processes. And then we've seen how things like Eclipse MicroProfile have led the way in terms of Agile development of specifications, and Jakarta EE is moving in the same direction. And we've seen how the runtimes have evolved to become more open. So essentially pretty much every runtime implementation of these technologies is open source, or at least every vendor has an open source implementation that's kind of production ready. And we've seen how those, well, we haven't really gone into much detail on those, but the nice thing about having open specifications and then different runtime implementations is you can pick and choose a runtime that supports the qualities of service that you need. So we go from a kind of spectrum in the kind of MicroProfile space of you can have your kind of traditional enterprise application server deployment all the way down to things like OpenLiberty, where you can pick and choose the pieces you need and create a runtime that's tailored to exactly what you need for your microservice. And even things like Quarkus are kind of innovating in the area of native runtime, so compiling to native, running a native application, so you get really fast startup, low memory footprint, and so on. But what we've not really talked about is the role of the JVM in the story. And basically not all the JVMs are created equal. You're probably aware of Hotspot. Hands up if you're aware of Hotspot. Okay, so Hotspot is essentially the JVM that's part of the OpenJDK project provided by Oracle. Anyone heard of OpenJ9? Okay, so OpenJ9, so IBM for many, many years, in fact since Java began, has had its own implementation of Java. And that was necessary from an IBM perspective because we had our own hardware, we had things like the mainframes, we had AIX and so on, so we needed to provide Java on those platforms. And then 2 years ago, around the same time we open sourced the OpenLiberty project, we also open sourced our Java to Eclipse. So the Eclipse OpenJ9 project was created. So this is all available under nice friendly licenses. It's actually dual licensed under EPL but also under Apache 2. And the really interesting thing about OpenJ9 is it was designed in the days of Java ME. Who's heard of ME? Okay. I like you at the back. You put your hand up often. Thank you. Except for OpenJ9. But so Java ME was essentially Java on the phone. So if you had one of these old Nokia phones, probably not grey enough to have had one of those, maybe you are. If you had one of those old Nokia phones, they ran Java. And the characteristics you needed for applications running on a phone is you want them to start quickly, you want them to run in low memory footprint, and you don't want them to have this kind of long ramp-up period. So you start your game on your little Nokia phone and you start playing, it's really, really slow, and then after 5 minutes the JVM's warmed up and eventually it's okay. That's not a great characteristic. So fast startup, low memory footprint, runs really quickly from the beginning. Does that sound familiar as a kind of set of cloud requirements? I mean, those are the characteristics you want from applications, Java applications written and running in the cloud. And so what we found was quite nice from a kind of IBM Java and therefore OpenJ9 perspective is that when we do measurements, we can see that compared to Hotspot, OpenJ9 actually has really good runtime characteristics for cloud-native applications. If you deploy a microservice to a cloud, quite often you're charged based on memory footprint, so you want it to not use very much memory. If you deploy a service to the cloud and it's maybe a short-lived service, you want it to start quickly and be available very quickly. And so these are actually, I love this, real data. It's not lies. So these are some measurements that were done comparing OpenJ9 with Hotspot, or both using, or all using the OpenJDK class library. And you can see that Hotspot takes a little while to warm up, but eventually kind of reaches this is essentially throughput, reaches the level that we get with OpenJ9. OpenJ9, again with the OpenJDK class libraries, it warms up a lot quicker and gets to kind of full throughput a lot sooner. And then interesting, we've got this concept of ahead of time compilation, where we will, rather than over time JIT things that we find that are hot, we can actually do the JITting ahead of time and the compilation ahead of time, so we get really, really good quick startup. Now you'll notice there's a cost to pay, so the throughput's lower, and that's something that we're continually looking at to improve. The reason why there's a cost to pay is essentially we don't have representative information going through the JVM to make the best optimizations. So when you're doing kind of jitting based on throughput, you can make better decisions in terms of the optimizations you make. Okay, so in terms of where to get Java, and this is kind of independent of whether you're wanting OpenJ9 or Hotspot or whatever, there's been a collaboration between a number of different parties, and it's kind of led by the London Java community around adoptopenjdk.net. So what adoptopenjdk.net does is provide pre-built binaries for various levels of Java. So here's just an example. I just happened to click on OpenJ9 because I like that one. I'm choosing Java 11, but you can see I can get the kind of latest development streams, and I can get older versions of Java and so on. Steve, do you want to say? I'm going to dump you in it. Do you want to say something about Adopt OpenJDK?
It's the best ever.
It's the best ever. So in terms of kind of support and things like that.
Adopt OpenJDK is this community gathering to produce binaries for it's more just Hotspot, I don't know. And we're all working together to give you one place where you can get Java built and tested in the same way. So whichever vendor you get, the build process and the testing process is all the same, just exactly the same level of code, built by the same set of people on all platforms, all the choices that you have. So that we have unique, we have the same content, so you're not worried about picking up Java from one platform. You can pick up Linux, Java, a certain version of Java 8. You can pick up one from a different version. You can go to Amazon and get a different version, as in build numbers. So the dot guys are trying to give you one set of version to get all the Java.
So it's consistency, and also fixes go into these builds on a regular basis. So. And I think some of the, and then you can buy support for them, can't you, for the various different ones? Yeah.
So with Java, you're not just, you don't have to buy support for Oracle, you can buy support for Oracle, IBM, Red Hat, Azure, Amazon if you want to go with them, and there's quite a few leader as well. So with the doc guys, again, you're not doing support, Jakarta EE support. There's lots of people who can offer you support for your job.
Yeah. All right, so summarize. So we've seen that enterprise Java has evolved to become more agile and more open. So the specification processes are more open, the runtimes are open source, and they're also agile. The spec processes are more agile, and the delivery of the technologies, the open source implementations, is much more agile. We've seen how, and this, personally, I think this is a great progress, how essentially Eclipse has become the home for enterprise Java specifications. The fact that we have MicroProfile for the cloud native side of things, and Jakarta EE as the set of kind of existing specifications that we can now evolve in tandem and in a consistent way is really, really nice. We've seen, as I've just mentioned, the specification process has evolved to, so MicroProfile delivers every 4 months, I think it is, so 3 releases per year. We've seen about the community, so the fact that there are 140 specifically for MicroProfile, 140 different committers, and many other companies invested in MicroProfile and Jakarta EE. We've seen that there's multiple open source implementations, so you're not locked into a particular vendor. If you buy into the idea of MicroProfile and Jakarta EE technologies, you can choose your vendor based on your needs, based on whether based on runtime characteristics, or based on maybe the company you have a relationship with. And we've seen from the MicroProfile perspective how it's been designed with first-class integration with containers and Kubernetes in mind, so being able to link up to Kubernetes liveness and readiness probes, being able to get configuration injected from Kubernetes config maps and secrets. We've seen how the runtimes have evolved to address the kind of new agile requirements in terms of being able to deliver new technologies, but also being able to, for example, just provision just enough runtime for your needs. And we've seen how you can mix and match the various technologies. So the example that Emily showed around starting out with a JAX-RS REST service with JAX-RS JSON-B, and then maybe adding in a health endpoint from MicroProfile, and then maybe adding in JPA to access a database. all as part of a nice consistent package. And also I mentioned about Quarkus, so about kind of emerging innovations. So a number of, as we said, you get the opportunity or the option of a spectrum of implementation choices around the kind of MicroProfile and Jakarta EE technologies, all the way from native all the way up to kind of full enterprise Java application server environments. And we just talked about the role of the JVM and how actually taking a look at different options in terms of JVM choices. There may be ones out there that actually fit or are a better fit for doing cloud native applications in terms of things like memory footprint and startup time. So that's all we had. I'm afraid we've gone over, sorry about that. Just some useful links if you're interested to the various community sites, open source projects and so on.